In this video, we're going to be discussing quadratic forms. So, to write a quadratic form, q of x, we write a vector, a variable vector, x, we write a symmetric matrix A, and then we write x transpose. Hang on a minute, I've got that the wrong way around. X transpose is here at the start, and x is here. So okay, but what does that mean? Say we have the equation 3x squared plus 4y squared equals, I don't know, 6. What we're doing is we're rewriting this left half. That's a quadratic form, and we're rewriting it. And what we're going to do is we're going to write it like this. This is a symmetric matrix A. This is x transpose. And this is x. And that is equal to 6. And you notice if we just multiply all this out, we end up with xy multiplied by 3x, 4y, and we end up with 3x squared plus 4y squared equals 6. So at this point you might be asking, okay, you've managed to rewrite something in a much more complicated way. Why on earth would you do that? Well, the matrix in the center here that we've used is symmetric, and that's intentional. And this, we've seen in previous videos about orthogonal diagonalization and spectral decomposition, that there are certain things you can do to symmetric matrices that you can't do as easily with other matrices. So this is intentional to make certain computations more easy. But you might ask, well, 3x squared plus, I don't know, 8xy plus 4y squared. What on earth, well, good question. Good question before you even asked it. Yes, we can do that. We do 3, 4, and then we take this and divide it by 2, and we do 4, 4 as our A, and then obviously we do xy and xy, and it's still equal to whatever's over here. Right now that's 6. And if we just do the matrix multiplication here, we end up with our original product. But notice we've divided it here to retain that symmetry, as we've discussed. Now, this becomes moderately more complicated, but not really when you move it to R3. So let's take the equation, I don't know, 3x1 cubed plus, I have to make up numbers on the spot, plus 4x2 cubed plus 5x3 cubed, that's very creative, plus, let's say 6 x2 x3 plus 8 x3. Actually, let's make that x. Yeah, let's do 6 x 2 x. Yeah, 6 x2 x3. Let's do 6 x1 x3 there, and 6 x. There we go. That's better. That's a more sensible order. Now, in R3, obviously, it's easy to just throw these guys on the diagonal, but how do we do that? How do we do the non-diagonal entries? Well, for the x1, x2s, we put them here and here. Now, in that case, this is 0. We don't have terms like that. And then for the x1, x3s, we put them here. 3, 3. And for the x2, x3s, we put them here. 4, 4. And voila, you have a symmetric matrix. That's great. And it's a quadratic form, and we can, obviously we'll need to write x1, x2, x3, because up until this point we've just calculated A. We actually need to write, that's the complete quadratic form. Alright, in the next video we're going to explain some of the applications and more complicated things about quadratic forms, but that is a basic introduction to quadratic forms.